In this example, we prove the product of three consecutive integers is divisible by 3. So first of all, we have three consecutive integers. Again, we don't know which these three consecutive integers are, so we won't be able to pick specific integers. Secondly, we multiply them and we show the product. After we multiply these three numbers, the product is divisible by 3, which means a multiple of 3. So what we need to do is we're going to, first of all, before we start, we always try to get an idea what we need to do on our scratch paper. So first, I have three consecutive integers, so I may do n as the first one, n plus 1 as the second one, n plus 2 as the third one. So usually that would be your first try. And let's see if it's going to work. And so I'm going to multiply all these three. Again, the reason we have to pick a variable because we have to use a variable to we can use variable to represent any integer. So we're going to multiply the first two, distribute n to both of them. We get n squared plus n times n plus 2. Now we use FOIL rule. We do n squared times n cubed, n squared times 2n squared, plus n times n, which is another n squared, and n times 2, that's 2n. And now we can combine like terms, n cubed, and these two will be combined as 3n squared plus 2n. And by working out, we can see these three terms we cannot factor out a factor 3. So because if you want to show n times n plus 1 times n plus 2 is a multiple of 3, we have to be able to factor out of 3 times some kind of integer. But by looking at the expression, we cannot factor out of 3. The only thing has a factor 3 is the second term, and the other two don't have factor 3. So that tells us if we pick n times n plus 1 times n plus 2, this will not work. And so we're going to try to see can we do the approach we did before in the previous example. Maybe we can consider the smallest integer is even integer. And so let's try this. If I do the first as 2k, and the second as 2k plus 1, and the third as 2k plus 2. And this time we won't multiply everything out. I'm just going to look at them. So this one has a factor 2. And this one cannot factor out anything. And this one we can factor out of 2. So if I factor out a 2 from here, this 2 together with this 2, that will give us a 4, which doesn't help anything. Okay, so I factor out a 2 from here, that leave us a k plus 1, and that 2 times this 2 gives us this 4. So it looks like I'm able to show if the smallest is even and the product of these three consecutive integers is divisible by 4 because it is a multiple of 4. But we need to show it is divisible by 3. So it looks like it's not going to work either. I did not try if the first number is odd. Even if we try that, it's not going to work because it does not even work for the even case. So that tells me I may have to consider, because we need a multiple of 3, so maybe we can divide all the integers into 3 categories. First category will be multiple of 3. So the smallest integer here, I'm going to say if n, the smallest of these 3, the smallest is a multiple of 3, which means is 3k, where k is integer. But of course, the smallest integer may not be a multiple of 3, and we will have to do the second case. What if the smallest integer is not divisible by 3. Maybe it's 3k plus 1 as if this integer divided by 3 has a remainder 1, then we can write this integer as 3k plus 1, which means a multiple of 3 plus 1. And there's one more case. Maybe the smallest integer is not a multiple of 3, not a multiple of 3 plus 1, but a multiple of 3 plus 2. And that's all these 3 cases we have. And if you say, well, we can do multiple of 3 plus 3. 3 multiple of 3 plus 3, that would be the same as a multiple of 3, because if you have multiples of 3 plus another 3, you can factor out of 3 to get k plus 1, which means 3k plus 3 is a multiple of 3. So there are only 3 cases, as we mentioned before. So now we're going to prove the case by case. So our goal is to prove the product of these 3 consecutive integers. So we take the smallest as 3k, which means the other two will be, the other 2 integers are 3k plus 1 and 3k plus 2. Now we multiply these 3 integers. The product will be 3k, the smallest, times 3k plus 1 times 3k plus 2. And in this case, there's pretty much nothing to do, because we've already seen a 3 right here. This is a factor 3, which means we can already see the product can be written as the number 3, integer 3 times another integer. So this is the format we need, 3 times a integer, which means any number, if it's 3 times an integer, this number is, of course, divisible by 3. Is divisible by 3. So the first case is very easy. Now let's look at the second case. If the smallest is 3k plus 1, then the other 2 integers are 3k plus 2 and 3k plus 3. And we do the product again. The product is going to be the smallest, 3k plus 1 times 3k plus 2 times the next integer, 3k plus 3. Now, don't multiply everything out, because we don't need it. All we need to do is to factor out of 3. And by looking at each factor, here 3k plus 1, there's nothing we can factor out. 3k plus 2, nothing we can factor out. But 3k plus 3, we can factor out a 3. So let's factor out a 3 from the last factor, which will give us 3. Let's put a 3 in front of everything and copy the rest of it. So this is still the first factor, the second factor, but for the third factor, I'm going to factor out the 3, in which I put it right here, and that will leave us k plus 1. And you can say this is also divisible by 3. By 3. Because, again, the product is written as integer 3 times another integer. So that apparently it's a multiple of 3. Similarly, we can prove the third case. So the product will be, the product is going to be the smallest integer 3k plus 2 times the next integer will be 1 bigger, 3k plus 3, and the 3k plus 4. And again, we look at each factor. The first one is not factorable, but the middle one, the second one, we can factor out of 3, which we're going to put the 3 in front of everything, and that will leave us k plus 1. And there's a 3k plus 4. Now again, this is divisible by 3 because we have a factor 3 right here. So sometimes we need to prove, it depends on, so there are many different cases to consider. So when we pick variables for these 3 consecutive integers, do we just take n plus 1, n plus 2, or do we take consider the first smallest as an even number and or the first as an odd number, and you really don't know which one will work. So you might start with the easiest case, and if it doesn't work, and then we divide all integers into two categories, even and odd. And if it still doesn't work, and you can try three categories, because any integer is either a multiple of 3 or multiple of 3 plus 1 or a multiple of 3 plus 2. So there are only any number is going to be one of these belong to one of these three cases. And sometimes you may need to consider dividing into four categories: multiple of 4, multiple of 4 plus 1, multiple of 4 plus 2, multiple of 4 plus 3. That's also possible. It really depends on what we need. So, but I think you should try the easiest case, and if it doesn't work, and then try the one with more cases.